Hello, welcome to the next lesson on chemical reactions. Like always, guys, I'm going to start off by doing some do now questions as well. So you'll have these in the workbook that you were given, and what I'd like you to do is attempt the answers yourself. So if you haven't got these, or you haven't got the workbook in front of you, pause the video now and write these down, and then we'll go through the answers together. The questions are, number 1, what are valence electrons? Number 2, how many electrons does lithium have? How many electrons does lithium have? And what part of the atom are electrons found? And there's a little hint there. It's two words. The first one starts with E and the second one starts with S. So if you want to pause the video now and attempt these, then I'll go over the answer. Okay. What are valence electrons? Well, valence electrons are the outermost electrons of an atom and related to the reactivity of an element. So we discussed that briefly in the last lesson, and we're going to talk about that in more detail today. How many electrons does lithium have? Well, lithium is third in the periodic table, therefore it has 3 protons, 3 neutrons, and 3 electrons. And what part of the atom are electrons found in? They are electron shells. And we've looked at the inner shell, which can hold 2, and the second inner shell is 8. So that is really important. We're going to be looking at these in more detail today and actually looking at some chemical reactions. So this whole term we're going to be talking about reactions that occur when we put certain chemicals together. And a lot of them are happening right now in your body that we don't even know about. Not this isn't happening in your body. That would be pretty obvious and pretty horrendous. If that was happening to you right now, you'd probably feel it. But chemistry is amazing. When you basically add different chemical elements together, they can take on completely different properties when they create a chemical bond. And what we're going to talk about today is some simple chemicals that we've hopefully heard of before and how they actually connect together using their electrons. So in the last lesson I talked about neon being really unreactive. Now neon is unreactive because it is number 10 in the periodic table, so therefore it has 10 protons and 10 neutrons. We can see that it has 2 electrons in the inner electron shell, so that's quite happy. And obviously if there's 10 protons per 10 neutrons, it has to have 10 electrons, so the remainder, the last 8 electrons are found in the next electron shell, and we know that 8 is the most that can be in that shell as well. So neon is quite happy. It doesn't have any electrons trying to get away. It's not trying to look for extra electrons, so it's a very stable element. Lithium, on the other hand, was the example we used, is trying to get rid of that electron as much as possible. It doesn't have a complete electron shell, and the reason it would probably try and get rid of that electron more than gain electrons is to be stable in terms of electrons. It only has to get rid of 1, but to fill that electron shell it has to find 7 electrons from somewhere else. So it's much easier for lithium to get rid of 1 than find an extra 7, and that's important as well when we talk about the next part. So if we look at these elements in the periodic table, what's really interesting is how they're arranged. So we had neon over here, which has 10, and we had helium. Remember, we talked about helium in the last lesson. Helium is number 2, so it has 2 protons, 2 electrons, and therefore it has a stable electron shell. It only has 2 electrons, but that's all it needs in the first one. Neon, I just discussed. So again, it has 2 in the inner shell, and then 8 in the next shell, making it stable. Argon, again, if we do that, so 2 in the inner shell, 8 in the next shell, and then that leaves it with another 8 to make 18. So what you'll find is if you go down the columns of elements, you will find that they all share similar properties in terms of the number of valence electrons. So the valence electrons in this group, they're all stable, so all the electron shells are full. And this group is called the noble gases, which you might have heard of before. They're called the noble gases because Professor David Christian, a historian who does the big history that you've seen before, He says they're almost too snooty, so they're a bit posh, so they don't want to mix with anyone else. So the noble gases are very unreactive gases because they already have enough electrons in their shells. If we go over here though, we have all these different columns, and you can see that hydrogen has one valence electron, lithium has one valence electron, so does sodium, potassium, rubidium. So all of these have one in this column. Therefore, this group of elements are highly reactive. And that makes it easier again to read the periodic table because it tells us a lot about what elements are probably going to react with what other elements. And we'll do a simple example here just now. So before I move on, we need to talk about what happens after an atom combines with a different atom. It's no longer an element, okay? Because elements are chemically the simplest substances and hence cannot be broken down using chemical reactions. So hydrogen is just hydrogen, oxygen is just oxygen, but when you combine them together, you create something different. It's not an element, it's not quite hydrogen anymore, it's not quite oxygen anymore. It's a combination of those two. And we call that a compound. So a compound in simple terms can be described as substances that have two or more atoms bonded together. So we're going to look at some of those today as well. A mixture is the physical combination of two or more substances in which the identities are retained and are mixed in the form of solutions. So a really easy example is a compound that we're going to look at would be H2O. H2, 2 hydrogen, 1 oxygen. We know that's water. So that's a compound. Okay, we can tell what's in there. We can break that down. A mixture would be something a little bit more complicated, like a chocolate milkshake, for example, because there is so many chemicals in that. It's not that easy just to break it down into the constituent parts. So we can just say, okay, there's hydrogen, there's oxygen, H2O. There's going to be calcium in there. There's going to be H2O in there. There's going to be a whole mix of compounds. So a mixture is something that is just really complicated chemistry in terms of we can't just break it down simply into, okay, there must be some hydrogen, there must be some oxygen. So we're going to be looking at compounds today. And this is basically a combination of atoms bonding together. So the simple example I wanted to use was hydrogen and oxygen. So if you look in the periodic table, hydrogen is number 1, oxygen is number 2. And from just even looking at the periodic table, we can visualize what the atoms look like. So we know hydrogen has 1 proton, 1 neutron and 1 electron. So it's looking for 1 extra electron to be full or get rid of 1. Oxygen is number 8, so it has 8 protons, 8 neutrons and 8 electrons. Therefore it has 2 electrons in the first electron shell, and the last 6 then to make 8 are in the second electron shell. We know that that electron shell wants to be full. To be full, it needs another 2. It has 6 in that shell, so it needs another 2. We'll look at that just now. So, like we just said, hydrogen here, 1 valence electron and 1 valence electron in this hydrogen. If we look at oxygen, we know it's number 8, so it has 1, 2, 3, 4, 5, 6, 7, 8 electrons. Now, it wants to gain 2 electrons to be stable as well. So we can do that. Oxygen can find these 2 electrons by taking the electrons that hydrogen has, or sharing the electrons, I should say. So we have 2H here, 1, 2H, and 1 O, excuse me. And we combine them together here. We get the 2H, and we can draw it like this. So this is quite complicated and quite a long time to draw. 2H and 1 O. And we can see now the hydrogen, by sharing one of the electrons from oxygen, now has 2 in its electron shell. It's quite happy. This hydrogen is sharing as well and has 2. It's quite happy. And oxygen now has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Total electrons, it has 8 in the outer electron shell. It's quite happy now as well. So when we look at this chemical reaction, on the left hand side, these elements are called reactants. These are the things that are going to react together. Once they react, then it gives us a product or produces this new compound. So it's important to know that on this side of the equation, the left-hand side, before the chemical reaction occurs, we call these elements reactants. And once they've combined together through a chemical reaction, the new compounds that are created are called products. Okay. So it's quite complicated. If you look at that, I mean, imagine you were trying to draw your chemical equation out and you had something like gold with 70 odd protons. It would take forever. So we have a more simplified version of doing this, and it's called the Lewis dot structure. And the Lewis dot structure is just related to the valence electrons. Okay, so we don't need to write the inner shell for most elements if they have that completely full, like oxygen does. Hydrogen has one valence electron, hydrogen has one valence electron, and oxygen has 6 valence electrons. So a really simple way that we can draw that is H, the chemical symbol for hydrogen, with a little dot. That little dot represents the one valence electron. This hydrogen atom, again, same thing, one valence electron. And then we can draw oxygen, which is the chemical symbol O for oxygen, and 6 valence electrons. So this is a bit quicker than drawing out the whole atom and everything else that's going on, all the protons and everything else. So this is called the Lewis dot structure and saves us some time, but it allows us still to visualize what's happening with the electrons. So if we combine those together, and I think if we change the color, it makes it easier to see, it's the exact same thing we saw as before. Hydrogen is sharing its electron with oxygen. It gains 2. It's pretty comfortable now. The same with the hydrogen on this side, and the oxygen now has 1, 2, 3, 4, 5, 6, 7, 8 in the electron shell, so that is happy and it is stable. So it's important to count the elements. We have to have the exact same amount of elements that we had to begin with. So we started off with 2 hydrogen, 1 oxygen. That makes H2O. Okay, 2 hydrogen we can write as H2, 1 oxygen we just write as O. So that's water, and that's why water is a nice compound to look at, because it's really easy when you see the valence electrons like that. It makes sense why they combine to make H2O, and everyone's familiar with that chemical equation, H2O, and that makes water. So let's look at a different example. Let's look at sodium and chlorine. So sodium and chlorine, we may have come across some of these in our daily lives. Chlorine, particularly in pools. Sodium you might not have came across, you might have heard of it before though. And we're going to do the same sort of thing to see what that makes when we combine them together. So we look at the numbers here. Sodium is 11 and chlorine is 17. So we could draw it out like this, which, you know, is going to take a long time, but we can do that anyway. So let's just go back and check again. 11 sodium, so it has 11 protons, 11 neutrons, and 11 electrons. Let's just double check. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, that makes sense. So it has a full inner electron shell. It also has a full second electron shell, and it has 1 valence electron. And remember what I said before, every element in this column, hydrogen, lithium, sodium, potassium, they all have 1 valence electron. So we can see that here, 1 valence electron. That makes sense. Chlorine, what number is chlorine? 17. Let's count. So there should be 17 protons, 17 neutrons, which aren't drawn here, just in the nucleus, and then 17 electrons. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So it's missing 1 here. It needs 1 more. So if we do the Lewis dot structure, we can do sodium, which is Na, that's the chemical symbol, has 1 valence electron. Chlorine has 1, 2, 3, 4, 5, 6, 7. So it needs 1, and sodium wants to get rid of this one, basically. That's fine. So the Lewis dot structure works quite well there instead of drawing all this out every time. And we can maybe write it like this. I'd advise you to use different colours because it makes it a bit easier to see. So sodium with its 1 valence electron plus chlorine with its 7 valence electrons makes sodium chloride. Sodium chloride. Don't worry too much about the plus and the negative at the moment. We're going to talk about that in a little second. But what I want you to do is count the elements on this side, we have one sodium atom, one chlorine atom, and then on the products, we have one sodium atom, one chlorine atom. That's really important, they balance out. And we're going to talk about that more in a couple of lessons' time. So we have one sodium, one chlorine. We write that as NaCl, so that's sodium chloride. And sodium chloride is actually table salt. So you've all, I'm sure, had table salt on your chips one day, or your fish and chips. That is the chemical reaction for salt, sodium chloride. And that's basically chemistry. That is what chemistry is all about. We can combine each of the elements on the periodic table and create completely different things from what the atoms look like. So by combining different elements in the periodic table, we create absolutely everything we see in the world today, from water, salt, rocks, bricks, grass, soil, air, plants, and humans. We're all made of different combinations of these elements in a very similar way to what I've just shown you. So if you think how many elements are on the periodic table, there's so many combinations and compounds and mixtures that we can make from that. It's fantastic. Okay, thank you very much. Puppy Hamish says, cows have best friends. That's not bad. That's all right. Hamish has got some dark facts as well, so that's a rather nice one. Cows have best friends. Thank you guys. We'll see you in the next lesson.